So here in this problem, we have a given condition that's a plus b plus c equals to pi radians. We need to prove the following. Let us begin. So we'll start our proof from the left hand side, where we have cosine squared a over 2 added to cosine squared b over 2 added to cosine squared c over 2. Now, what we'll do in the next step, we are going to convert cosine squared in the second term and in the third term to its sine squared equivalent by taking the help of the fact that sine squared theta added to cosine squared theta, that's always equals to 1, and we can always express cosine squared theta in terms of sine squared theta as 1 minus sine squared theta. So what we'll do, we're going to transform, we'll keep the first term intact. We're going to only transform the second and the third term. So the second term becomes 1 minus sine squared b over 2 added to 1 minus sine squared c over 2. Okay, so 1 and 1 that gets added to give us 2. So that takes care of the term which is 2 on the right hand side. And then we now write the first term cosine squared a over 2, and then we consider the term that is negative sine squared b over 2, and then we have the last term that is negative sine squared c over 2. Now we converted cosine squared to its equivalent sine squared, because what we have now is a formula cosine squared a over 2 minus sine squared b over 2. That means this is of the form cosine squared alpha minus sine squared beta. So whenever we have cosine squared alpha minus sine squared beta, this is given by the product of cosine of alpha plus beta and cosine of alpha minus beta. Okay, meaning we can now combine the difference of the two trig functions in the parentheses to get cosine of a plus b over 2 multiplied to cosine of the difference divided by 2. So we have a minus b over 2 minus sine squared c over 2. Okay, now let's try to work with cosine of a plus b over 2. Here we're going to make use of the fact that since a plus b plus c equals to pi radian, so can we not say that a plus b equals to pi minus c? Now we're going to divide both sides with 2 such that we get a plus b over 2. That's going to be equals to pi minus c divided by 2. Now we're going to take the cosine function of both sides. So that gives us cosine of a plus b over 2 on the left hand side, and on the right hand side we have cosine of pi over 2 minus c over 2. What is cosine of pi over 2 minus c over 2? So this is simply sine of c over 2. In other words, what we have shown here is that we have shown that cosine of a plus b over 2, this is exactly the same as sine of c over 2, provided that the sum of the angles a, b and c adds up to pi radians. Okay, so we have 2 added to, now in place of cosine of a plus b over 2, we can replace it with sine c over 2 multiplied to cosine of a minus b over 2 minus sine squared c over 2. The whole idea of converting cosine of a plus b over 2 to sine function is now what we can do. We can take sine c over 2 as the common factor. So we take sine c over 2 as the common factor. So this is going to now leave us with cosine of a minus b over 2 minus sine of the angle c over 2. Now we rewrite the expression. All we have to do is, again, we have sine c over 2 as the second term within the parenthesis. We will transform it back to the cosine function such that we can have the difference of two cosine function, and that becomes easier to compute. So we have 2 plus sine c over 2 multiplied to cosine of a minus b over 2. Now in place of sine c over 2, we're going to replace with cosine of a plus b over 2. The why we have done this, because we have the difference of two cosine function. We know that since cosine of alpha minus cosine of beta, that transforms to give us 2 times sine of beta plus alpha over 2 multiplied to sine of beta minus alpha over 2. Okay, so this is going to be equals to 2 added to sine of c over 2 multiplied to 2 times sine of the angle. So we will consider a minus b to be equivalent to alpha and a plus b over 2 to be equivalent to beta. We need beta plus alpha over 2, so that is going to give us a over 2. and beta minus alpha over 2, that's going to give us b over 2. So we now have 2 added to 2 times sine of angle a over 2 times sine of angle b over 2 times sine of angle c over 2, which is exactly the expression on the right hand side. So let's verify it once more. So we needed 2 added to 2 times the product of sine a over 2, sine b over 2 and sine c over 2. So we have successfully showed that the left hand side equals to the right hand side. Hence